everyone, and welcome back to my channel, where today we're going to be discussing algebra tricks. So the first trick we're going to be discussing is the last digit of powers. Last digit as referring to the ones digit. The last digit of powers. Has a question ever come to you like this? What is the last digit of 212 to the power of 576 plus 357 to the power of 143? This may seem like a very tedious question, but fear not, since to this there's a very simple method. So, first let's take something such as 2 to the power 5. It's 32, so the last digit or the ones digit would be 2. So to find the ones digit, we take the sequence of digits starting from the first ones digit we have, which is 2. Since we know that it's 2 to the power of 1 first. Then we multiply 2 again and again like this. In this sequence, we never include 2 to the power of 0 because that will always be 1. So you have 2, 4, 8, 6, 2, 4, 8, 6, and so on. The reason when we multiply 8 by 2 and we get 6 is because we only want to see the last digit. 8 times 2 is 16, yes, but we only take the last digit, so 6. And the fifth number, or the fifth term, is 2, meaning that the answer for 2 to the power 5 is 2. It is 32, but the last digit is 2. We take the fifth term, do the exponent, the number above the base of the power, being 5. But if you look at this pattern, you can see the pattern 2, 4, 8, 6, right? Since there are 4 numbers repeated in this pattern, 2, 4, 8, and 6, we can say that with 2, there is an order of 4. So, if we do the same things with the powers of 1 to 9, because that's all the digits we have, we get these sequences here. Like, for example, 1. 1 is 1 to the power of 1 is 1. 1 to the power of 2 is 1. 1 to the 1 cubed is 1. 1 to the power of 4 is 1. So the order is 1 because there's only one number here, 1. The same goes with 5 and 6. You only get 5 and 6 as the endings again and again. Meanwhile, if you have an order of 2, you would have 4 and 9. 4, it's 4, 6, 4, 6. It goes 4, 16, 64, and 256. And the same goes with 9, which is 9191. Then we have 4. 4 is the most common one, as you can see in this table. We have 2, 3, 7, and 9. And we also have, 2, 3, 7, and 8. So, if you ever calculate that there's an order of 3, then you most technically must be wrong. Because 3 is not shown in this, so you'll never get an order of 3. But now you might be thinking, why are we using 3s? So if we go back to the question we just had, we know that 2 has an order of 4. 2 to the power 1, 2, 2 to the power 2, 4, 2 to the power 3 is 8, and 2 to the power 4 is 16, where we take the 6. And the exponent, usually how many terms are in the sequence, is 5. Because technically, if you have the exponent as 5, you're saying 2, 4, 8, 6, 2. And the last digit would be your answer. We can do this more quicker by doing 5 divided by 4, where 5 is the exponent and the 4 is the amount of the order, and you get 1 remainder 1. But you can just take away the quotient because we want to look at the remainder here. It's remainder 1. This remainder 1 would be 2, since the first one in the sequence of 2, 4, 8, and 6. So we're technically saying remainder 1 would be 2. Remainder 2 would be 4. Remainder 3 would be 8, and remainder 4 would be 6. So technically, since the divisor is 4, If the number is divisible, you can say that it ends in 6 in this case. But this means we can say this. The exponent of the power divided by the order of the number is equal to x, which is the quotient. It doesn't really matter what it is. And plus the remainder of the placement of the last digit in the order sequence. This may look really complicated, but in other words, we're basically doing the same thing we just did before. We took the exponent 5, the order was 4, we got 1, remainder 1. We can just take away the 1, and the remainder 1 is basically the first term in the sequence of 2, 4, 8, 6. You take 2. It's easy as that. So this may also look very hard, but you can just substitute, and this formula will do all the hard work for you. So we can go for the question we mentioned before, the very tedious question. If you don't do it with the trick, what is the last digit of 212 to the power 576 plus 357 to the power 143? So we can go first for 212 to the power 576. Since 212 is such a big number, it would be tedious to find the order, you thought, because you would do 212 to the times 212. But remember, we're only using the last digit, so we only technically have to multiply the last digit. This means we can take away 21 and you can get 2 to the power 576. This means that technically it's asking what is the last digit of 2 to the power 576 plus 7 to the power 143. This is simplified a lot now. So all we have to do is take the orders of the bases 2 and 7. So 2 has an order of 4 and 7 has an order of 4 again, as we said from the table before, where 7 is 7, 9, 3, 1. So now we know that the divisor both have to be 4. Meanwhile, we take the exponent. We got 576 before with the 2 and 143 with the 7 as shown in this slide. So we divide both of these numbers by 4. 144 has no remainder, so it technically has a remainder of 4, which means it ends in 6. Meanwhile, 143 gets a remainder of 3. This means if it has a remainder of 3, the last digit would be 8. So to find the answer, we add the two last digits together, which is 6 plus 8, which is 14. The reason we add, because we said here, what is the last digit of 2 to the power 576 plus and 7 to the power 143? Which means that you're technically adding the two last digits again, and the last digit of that sum is the answer. So we take the ones digit only, so the answer is 4. See? It was really that simple. Okay, let's move on to the next slide. So find the last digit to these questions using the trick we learned. You can rewind the video to see the steps again. And if you want to copy down the question somewhere else, you can pause this video. So, my questions to you. You can also pause the video right here because this is your time. Find the last digit of 56 to the power 31. Find the last digit of 143 to the power of 89. And find the last digit of 24 to the power of 25 times 55 to the power of 25 plus 67 to the power of 49. They may all look tedious, but with a trick we learned and your own maths logic, you can do this. So pause the video or rewind if you want to see the steps again. And after this dialogue or speech, I'm going to take the next slide in 5, 4, 3, 2, 1. Let us move on. And I hope you paused the slide already to see to have solved the questions. And We'll see if you're correct. Okay. So the last digit of powers, the answers. So the last digit of 56 to the power 31. We can simplify 56 into 6 because remember, all the other digits in the base don't really matter except for the ones. 6 has order 1, which is 6, 6, 6, 6, which means the answer will definitely have to be 6 because any number that has the last digit of its base as 6 will definitely end in 6 because it has an order of 1. For example, here for 5, you have 5, 25, 125, 625, and it goes on with 5, 5s, and 5s because 5 times 5 will always be 25, which ends in 5. So, here's a trick. As I said now, any power that has its base ending in 1 will have its answer end in 1. 5 will have its answer end in 5, and 6 will have its answer end in 6. These are the free numbers that only have order 1. Because digits with order 1 do not change their last digit when being multiplied with themselves. So the answer must be 6. Let's see for the next one. So find the last digit of 143 to the power of 89. We can simplify 143 into 3. So 3 has order 4, which is 3, 9, 7, 1. So the exponent is 89, so we do 89 divided by 4, which is 22, remainder 1. The first number is 3, so 3 is the answer. Now check your answers for the next one here. So find the last digit of 24 to the power 25 times 55 to the power 25 plus 67 to the power 49. So first, we can simplify the powers because they already look tedious by themselves. We simplify the 24 into 4, the 55 into 5, and the 67 into 7. The 4 has an order of 2, 4, 6, 4, 6. 5 has an order of 1, 5, 5, 5, 5. And 7 has an order of 4, 7, 9, 3, 1. 5 to the power 25 will end in 5 already, but we have to calculate the others. The others are 25 divided by 2, which is 12 remainder 1. The first one is 4, so you get 4. 49 divided by 4, 12 remainder 1 again. So you get the first one as 7, which means that if we're only doing this equation, the last digits, you get 4 times 5 plus 7. We can do this according to the order of the operations now, which is brackets, indices, exponents, whatever you call them. And then it's division and multiplication, then addition and subtraction. So first the multiplication, 4 times 5 is 20, plus 7 is 27. You take the last digit again, so you get 7. This means the answer is 7. So the answer to the three questions respectively is 1. The question number 1 is 6. Question number 2 is 3. And question number 3 is 7. I hope you learned something from this trick. And if you ever face this question again anywhere in a paper or your teacher gives it, share your knowledge maybe. And just solve the question quickly. Also, I recommend you to share this knowledge with your friends and family by sharing this video and like and subscribe and ring that notification bell for more. And I really thank you for watching. You watching this video means a lot to me, seriously. So please like, subscribe, ring that notification bell for more great content like this. And I'll see you in the next maths trick and other series I might be making. Goodbye.